Hi, good morning. This is Patrick Shea with the Applied Products Plumbing team, and today I'm going to be talking a little bit about Water Control Corporation and specifically rainwater harvesting. It's a process that for years people liked conceptually, but the return on investment on this was so far out that it always was something that was VE. But we've had a couple of changes in the industry that have kind of helped push this forward. When you look at a rainwater harvesting system, you have an infrastructure of roof piping and gutter piping that brings all the water into either a single or more likely a series of, in Massachusetts or New England, we're going to be primarily underground storage tanks. The filtration and delivery side, what we've got is a skid package with pumps and various sanitation methods to clean the water, keep the water in the tank clean, and then deliver it for its use. Primary uses in New England for rainwater harvesting are going to be irrigation, toilet flushing, and cooling tower makeup water. So these will be all non-potable water applications. Many municipalities are demanding that on new construction, you put the infrastructure for the rainwater collection and the cistern in place, and then they're allowing a delayed release to either storm or sewer, depending upon what the municipality allows for getting rid of that. So a big chunk of the cost of this system is now going to be put in place anyway. So now the added cost of adding a skid package and then using that water in the building is a little bit more appealing. So two different types of packages or two different types of filtration systems that we're using. The two most common ones are going to be UV or ozone. There are other chemical systems that are available, but really those, they have added certification requirements, and the costs kind of drive those away. And for the end use on the water, both of them more than meet what you're looking for standards on water quality. When you look at the system package, here's a picture of the 160 gallon per minute UV system by Water Control Corporation, and down here is the 150 gallon per minute ozone package. You'll notice there's a lot of common components to it. They all have a control panel, the buffer tank, various pumps for delivery to the building and recycling to the cistern, and then safety valves and pre-filters. Now across the board on all the WCC projects that they put together, they have what they call the concept of commissioning, and that works for water softening, high purity water filtration, and rainwater harvesting, and they all follow the same type of phases. The first phase is going to be gathering all the information you need to design and size the system. And in some cases that would include a water sample. So we all have kits that we can go out on site, get a water sample, send it in, and water control tests everything out. Secondly is what they call their design stage, and what that's going to be is we're going to design the system based on what they're looking to accomplish, the size of the system they need, and from there we're going to be able to give not only a full Division 22 written specification, but CAD drawings, submittal pages, and then we will get a quote from Water Control Corporation that we'll use to quote the system, sell it, and move forward. We go to the fabrication, and that's all done out at their plant in Minneapolis, where they put together the packages and ship them out. And finally is commissioning. And for that side, our DD services are certified and licensed to go out on site and do all the commissioning. So we're able to get another fee on the sale without having somebody from Water Control Corporation come in and do all the commissioning. So on the engineering side of this system, we are adding a lot of value to this project to our engineers, because although when you look at the information we need to design a system, how much rainwater can we collect? How much rainwater does the building need? What is peak flow? What is the cistern filtration flow demand? Engineers are pretty good at doing number 2 and 3, but number 1 and 4 is where we really come in and step forward and help them. All right, so when we get a project and we know some of the information on it, we use this spreadsheet, basic project information up at the top. Over here on the right, we have a website we can go to, so we can go to any town in New England and get the monthly averages. Luckily, across the board in New England, we're pretty consistent with not only rainfall in the whole area, but also per month. So we can use a monthly average on identifying exactly or calculating out exactly how much rain we're going to be able to capture each month. So on the project that I did recently with one of my engineers, they had a roof that was 76,000 square feet, and using the monthly average, taking into consideration that you can only actually capture 63% of that rain because the rest is going to wash away through the pre-filter process, you're going to be able to collect about 148,000 gallons of usable water. So that's what we know we can collect. So the next phase is to identify how much do we actually need. And for this project, it was just going to be used for toilet flushing in the school. So to get that number, we're going to go by the number of people. They had 550 male and female students. They had 95 male and female staff in the building. And from there, we'll be able to calculate what they're going to use on a monthly basis for toilet flushes. The project had 44 flush valve toilets and then a dozen urinals. So from these calculations, using your standard flow rates on it, we're seeing that they're going to need 72,000 gallons of water a month for their toilet flushing. So as you can see, we can collect 148,000, but we're only going to need 72. In this case, what they've done, and it's not uncommon to see this, is they've used multiple storage tanks in different locations around the building, and we only needed to tap into one of it. And then collecting the size of the tank, since we do have rain coming, consistently through the month, and it doesn't all come at once, we can calculate the cistern tank size between a quarter and a third of the monthly usage. So in that case, what they did is they went and they said, okay, we're going to need a little over a third or a quarter. They went with a 25,000 gallon tank because they wanted that. So now we're getting other information using the fixture counts for the urinal and the flush valves. What we can see is that a peak flow to the building is going to be 143 gallons per minute. So we have to size a skid package that could do approximately 143 gallons per minute. Now keep in mind that all of these flush together, it's 143 gallons per minute, but it's only for about 3 or 4 seconds. So an average flush on that would be between 12 and 15 gallons. And we can use the buffer tank on the skid to protect us on that. So typically what we'll do is we'll take that 140 and downsize it a little bit and go, in this case, we'd go with a 120. As I said, it's very important to keep the cistern clean, and the process we do with that is we're going to cycle the water in the cistern through the treatment skid 2 times a day in a 12-hour cycle. To do that, we'd need a pump that does just under 70 gallons a minute. So the recycle pump on the skid would be rated for about 70 gallons a minute, and then the delivery one would be rated for 120 gallons a minute. And then from there, we can just go back to the skid package sizes. As you can see, we have on the sizes for these, both the UV and the ozone, we're anywhere from 10 gallons a minute up to 240. In this one, they wanted to go with UV, so we selected the UV 120. If this was going to be an ozone package, we probably would have gone with the ozone 150. And from there, now we've got information that the engineer's confident in our selection, and we can bring it over to WCC, and they can start getting us all the documentation that we need to get this specified and move forward. Thank you very much. If you have any other questions on how we size our various systems, reach out to the APP team. Be happy to do it. Once we're done with all this and we put it in there, then the boys at EP go to town and sell it. Take care. Thanks.